Hi. So in the last episode, we gave a lot of definitions and some properties, such as the one-shot deviation or one deviation property or principle. Okay. So essentially, so here we're using this video to shortly give some explanations or some interpretations of that. Okay. So essentially, one deviation property says that given an extensive game, and essentially, and especially it has to be a finite extensive game. Okay, so this strategy profile is a subgame perfect equilibrium of gamma. Okay, if and only if for every player I and every history. And if this player I is going to play after some history H, then we have this inequality here, which says that the outcome for the equilibrium strategy profile yields a weakly higher utility or is weakly preferred than all the other strategies for player I. Right. So the important part is actually this part here, right? So essentially it says that, so this is true for every SI in this gamma given some history H. So this strategy only differs from the strategy in equilibrium given some H, history H, only for the action where this player I is going to move, and that's should be the initial one or the first action, or it prescribes after the initial history of the gamma H. Okay, so essentially this one-shot deviation or this one deviation properties addresses this equivalency between the SPE and the this requirement here, right? So so the proof has two parts. Okay, so for the first part, it's simply by the definition, right? So if this strategy profile is SPE, then it automatically satisfies the conditions, right? So that's the first part. And for the second part, for the other direction, okay, so it will be a longer proof. Okay, so it's basically essentially it's proved by the contraposition. Okay, so here suppose that this, so because we're trying to show that if there is a if there's no one-shot deviation, right, then this is a subgame perfect equilibrium, right? So that's what we want here in this direction. But here we're using a contraposition to say that if suppose if this S star is not a SPE, okay, so later we'll try to construct some, or we can try to find this one-shot deviation, right? So that's what we want here. Okay, so if that's true, then the contraposition statement will be true, so, which is that if there's no such that a one-shot deviation, then this is a SPE, right? Okay, so let's start with that. So suppose this S star is not SPE, and suppose this player I could deviate profitably in this gamma with some pretty random history H prime. Okay, that's where we start here. And then there exists a profitable deviant SI of player I in this subgame. Okay, so where this given the history H, okay, so the strategy for player I SIH. Okay, so this is not the same as the given the in the subgame right here. In the subgame of the given the history H prime for this for the previous one, strategy for player I in equilibrium and for in the history H, right? So, and that is for a number of H not larger than the length of length of the subgame, okay, given the history H prime, okay. And since this gamma has a finite horizon, so this number is finite, okay. So, and essentially, so among all the profitable deviations of clear I in this subgame with H prime, so choose this SI for which the number of history H such that this is true, and the strategy, okay, so the deviation, so the number of deviations is minimal, okay. So this is something that we going to choose here. So we're trying to deviate, but as less as possible, okay. So the number of deviations should be the minimal here, okay. That's what we want to have here. All right. So, and then let the H star to be the longest history of H, longest history H of the subgame with H prime, okay, for which there is a deviation, right? So essentially this means that this H star, okay, so this longest history H star, it means that now we have the minimum deviations in the strategy, okay, and also this is H star will be the longest history of that, okay. So as far as we can go, so it will be include all those history that we have for a minimum deviation, right? And that's what we have here. And then the initial history of the gamma H star is the only history in the gamma H star at which the action prescribed by SI differs from that prescribed by SI star given the H prime, okay. And this SI given H star, this has to be a profitable deviation, okay, in the subgame of H star. Okay, this is true because, so if it's not true or otherwise, then there would be a profitable deviation in the subgame of H prime that is different from the SI star given H prime after even fewer histories than does SI, right? So it'll be, because we have said that it was a minimum and it was a long we're using the longest history, right? So if that is not a profitable deviation, okay, so if that's the case, then what we have is that the we could even have fewer, or we could have less deviations, right? Because that is not a profitable deviation, then we could just discard that, right? So we could have fewer histories than that. So it means that this has to be a profitable deviation, right? Okay, so here we said that, so this SI given the H star, this history would be just a profitable deviation in the gamma of history H star that differs from this SI star H star given H star only in the action that it prescribed after the initial history of the gamma given the gamma of the history of H star, right? So essentially, here we have shown that this this one-shot deviation or this one deviation would be just it is a profitable deviation. Okay, so by here we could see that this is we have shown that this suppose this S star is not SPE, right? Then this player I could deviate profitably here, right? And we have constructed this as the one-shot deviation, since it happens only in the longest history, and this would be the has the minimum number of the deviation in the strategies, right? And in that subgame of the with the history, with the longest history, so in that subgame the deviation would be just the first action done by that initial player in that subgame with the longest history, right? So from here, then we could finally construct that profitable deviation, right? Okay, and so in other words, if we cannot find any profitable deviation, so essentially means that there will be an equilibrium, right? So, and that equilibrium will be just the sub-imperfect equilibrium, right? Okay, so this is a interpretation and some intuitions for this one deviation property, and hope this will be useful later. Okay.